This is Takahiro with Malicious file for exploiting forensic software. So let's give a round of applause for Takahiro.
Hi, I'm Takahiro Haruyama from Internet Initiative Japan. That is a Japanese internet service provider company. I'm interested in anti-forensics. So last year, I spoke anti-memory forensic method at Black Hat EU. Today, I talk about anti-disk forensic method to exploit the library component included in commercial forensic software. First of all, I introduce myself. My mission at the company is incident response, such as digital forensics, malware analysis. I made presentations or taught in hands-on classes at several conferences. And I distribute some tools on my blog. I also have NK certified examiner since 2009. Please follow me on Twitter if interested. This is today's summary. First, I want to make the background clear. To exploit bugs of file viewer component in forensic software called outside in. Next, I explain how to fuzz it. Then I demonstrate anti-forensics misusing two vulnerabilities detected by the fuzzing. I also refer to countermeasures. Finally, I summarize my presentation. I explain background and motivation. Function viewing file content is required in forensic analysis, and most commercial tools adopt the same library. For instance, NCase, FTK, X-Phase Forensics, and things like that. The library is Oracle outside-in technology, originally developed by Stellant. Since outside-in can analyze, extract, convert over 500 different file types data, it's used by not only forensic software, but also enterprise one like Microsoft Exchange, Security Agent, Semantic Enterprise Board, and so on. This means the impact is very large when exploiting the vulnerability of outside-in. Practically, several bugs of outside-in were reported last year. If still exploitable, lots of forensic investigators are exposed to risks of anti-forensics, such as process hang-up, malware infection. Forensic software often needs privilege that indicates malicious code execution on forensic software process can do everything on the system. For instance, attacker may own forensic workstations for government organizations. It can be an advanced targeted attack. That's why I initiated an investigation about the exploitability. I performed fuzzing to discover bugs in outside-in library. I briefly showed the implementation. This is an outline drawing of the further implementation using NCase. It's composed of three factors. First, I use minifuzz, that is a file format fuzzer provided by Microsoft. It mutates input files and run NCase. Next, custom script called NCase nscript invokes outside-in functions to display files. By the way, NCase usually detects minifuzz and terminates it immediately because minifuzz debugs NCase to monitor exceptions and register values at that time. So I wrote a kernel driver to prevent detection. We have two methods to call outside-in function using the NCase nscript. Get the doc view and write transcript in document class I wrote an script to call both of the methods. And for your information, usually nscript cannot receive command line arguments from ncase, so I used third-party tool to pass arguments to the script. If the minifraz catches any exception on ncase, it outputs the log like this and saves the mutated files like this. In my experience, the further discovered one bug for about 10,000 files. Next, I analyzed the two files generated by the further in more detail to identify the kinds of vulnerability and exploit them. As a result of the analysis, I introduced two examples of anti-forensics. They are process hang-up using infinite loop DOS vulnerability and arbitrary code execution using heap overflow vulnerability. I tested them on two forensic tools, Ncase and X-Ways Forensics. The latest version of outside-in is 841, but both tools still use or recommend the old version. And practically, there are two versions in Ncase, version 6 and version 7. I think most Ncase users prefer 6 to 7, correct? Could you raise your hand if you do a forensic investigation using Ncase? Oh, and mainly use version 6? Okay, most people. Anyway, if you install Ncase 6, outside-in 835 will be installed by default. In case of version 7, 840 is installed. On the other hand, we can select 837 or 841 in the installation of X-Ways Forensics. But X-Ways recommends 837 for web history examination because HTML preview function of index that does not work in the latest version. That's why I selected 837 for testing. The first example is process hang-up. The vulnerability included in the function passing Hangul word processor format document. Using the bug, a malicious file can cause infinite loop in a specific DLL routine. The vulnerability affected all versions, but Oracle released the fix 2 weeks ago. So I hope all software vendors embedding outside-in will update as soon as possible. I show the demo on Ncase 7. The OS is Windows 7. Run Ncase 7, open case, and access to the malicious file. Call outside-in function by clicking the doc view, then Ncase process has been freezing. The CPU usage is about 100%, and the user cannot operate anything. I know it's not funny, but effective for delaying forensic analysis, especially when processing massive files automatically, for example, keyword searching. In such a case, the investigator cannot have a clue about the cause of hang-up. The second example is arbitrary code execution. The heap overflow flag is included in the function parsing Ichitaro format document, that is a Japanese word processor. The heap overflow, as a result, a corrupted file can overwrite heap chunks in memory. The vulnerability affected H37 and earlier, but Oracle also recently released the fix. Therefore, I expect software vendors using the vulnerable version of outside-in will update at once. I fill in the gaps on some tricks for exploiting heap overflow. As you know, Vista or later Windows OS adopt various mitigation techniques to prevent exploitation of heap corruption vulnerabilities. For example, look-aside list that is not protected by safe unlinking has been replaced by low fragmentation heap. Besides, heap entry metadata randomization and randomized heap base address are introduced. As a result, misusing heap metadata is very difficult. One promising method for exploitation of heap overflow is overwriting function pointers in heap chunks. But the offset values to function pointers are not constant because it depends on heap allocation status. Heap spray allows us to put our shellcodes at a predictable address. For heap spray, we need to fill chunks of memory in the heap before gaining control over program counter. Web browsers and AdVReader provide an easy mechanism to do this. They have scripting support, so you can use JavaScript, VBScript, and ActionScript. What about forensic software? Unfortunately, it does not support them. Consequently, I use the heap spray technique with bitmap images. Checking images such as JPEG, GIF, bitmap on forensic software is a very common operation. And most forensic software supports displaying several images at the same time. In order to trigger a bitmap heap spray, for example, in NCase, use bookmark page as image in doc view, then make the bookmarked images set included. Set included means displaying all items recursively. In X-ray forensics, simply double-click image files. This is a debugger window attaching to NCase 6. After heap spray, large heap chunks are allocated to put the shellcode at a specific address. And once function pointers are overwritten like this, an indirect call execute the shellcode. Since NCase 6 does not activate dep, so we can execute from this address. If dep is enabled, we need to put the rope gadgets at this address. It's more complicated, but of course possible. It's demo time. I start with NCase 6, then X-ray forensics. The OS is Windows 7. Run NCase and open the case. First, check normal file using outside in. I can view the file content. Next, if I would like to see all bookmarked items, set included and select gallery. The ordinary operation causes heap spray. Then clicking the malicious file triggers heap overflow and overwriting function pointers. As a result, shell code is executed. In this demo, it runs calc. It's funny. Okay, next, X-ray forensics. Run X-rays, open directory, and view bitmap images. Heap chunks are spread. And click the malicious file, then calc is executed. That's it. Yes?
Quick question. Do you use the same bitmaps to exploit X-Ways and NGAs?
Yes, it's the same file. So in this way, one corrupted malicious file makes it possible to execute arbitrary code on multiple forensic software by exploiting the bug of the common library. However, honestly speaking, the success of code execution is unstable because function pointers called in a short time after overflow must be included in overwritten area. To improve the probability, we need to manipulate heap chunk layout before causing overflow. From now, I explain some countermeasures. To prevent overflow, of course, buffer boundary checking is essential. And Vista or later provides heap enable terminate on corruption option through heap set information API. If the option is enabled, the process terminates immediately with status heap corruption error. This debug window is NK7. NK7 enables the option by calling heap set information and passing value 1 as heap information class. That means heap enable terminate on corruption. So I could not execute arbitrary code by heap overflow on NK7. And in order to prevent bitmap heap spray, disable the operation causing it. For instance, in NK6, enable pictures in doc view option and uncheck for pictures to option. In X-Rays, we can display multiple pictures on the view using another method, so it's no problem even if the options are disabled. As common countermeasures, I recommend to use the latest version of Sidewind. Because 8.4.0 or later probably seems to fix all bugs except the infinite loop DOS bug discovered by my father. If you want to use NK6, you can choose an installation without file viewer. Instead, configure for using native applications. For example, set Microsoft Word for viewing doc and docx files. Last but not least, configuration of exploit mitigation like emmet and app locker is also effective. Yes?
Just one question. Is we need the latest version in both sides or just on the investigator desktop?
Could you say again?
Yeah, you need to have that version of NKs just in the investigator desktop with the latest version, or there is any DLL or on it on the client side as well.
I tried it, but it seems not to work. Okay? I wrap up my presentation. I told you the risk when examining unknown files acquired in forensic investigation. The file viewer is more fragile than you think, especially if old. Practically, the two bugs may be just a little bit of the problem because several bugs still remain in the old version. For example, in the function parsing Microsoft Word doc file, PowerPoint, and things like that. So investigators should pay attention to the security settings of their workstations. And forensic software vendors tend to use an old version of the component. Therefore, I think they should update their products as soon as the latest version of AuthCycling is released. Much the same is true on enterprise software provided by Microsoft, IBM, McAfee, Symantec, and so on. That's it for today. Thanks for coming.